Now, we can't model these expressions using algebra tiles because we don't have algebra tiles because we're doing this online, but if you, I'm going to give you a framework for thinking about this. Let's see if I can, should be easy. Okay. If you think of the x's as something one-dimensional, because these are all x to the first power, right? And then you think of the y's also as something one-dimensional. I should be consistent here. So the y's are also one-dimensional, but not necessarily the same distance as the x's. There's no reason for x and y could be the same, but they don't have to be the same, and so you can't combine them. They're not like terms. And so when you're simplifying this expression, you can subtract 2x's from 4x. Like let's go back to the x and say the x was 2. If x is 2 centimeters, for example, if I have 4 times 2 centimeters, I have 8 centimeters. I can take away 2 times 2 centimeters. They're the same amount of centimeters. I'm counting the same thing. So 4x's minus 2x is just like $4 minus $2. It leaves you with $2, or in this case, 2x's. You can subtract or add like terms. But the 2y, there's no other term with y in it, so that just remains 2y. And the 4 is just 4. There are no other. If I had plus 4 plus 10, then I could say 14, but this is my final answer. When you're doing a problem like this, considering a variable expression and combining like terms, you go from the unsimplified version to the simplified version, and your answer just is the simplest form. If you had written it, of course we know we can associate, so if you had written it 2y plus 2x plus 4, that is of course equivalent.